Long time ago.
Yeah, I bought one too. Okay, so we just got to sit uncomfortably close the whole time.
Yeah, it's all good.
Yeah.
The toastiness of the fire will make us want to rush it faster.
Okay, so nice to see you in person. Thanks for coming by, Jonathan.
Thanks, Bob. Thanks for having me.
I really appreciate this, and I'm excited for the future of working together with you and building out the AI, IoT cloud for the coming future. So before we get into talking about the new OpenMV cams a little bit, I just want to know a little bit more about Golioth, like why you started it, what you're trying to solve, et cetera, et cetera.
Yeah, so good part of my career has been in and around IoT, working with product companies, working with platform companies. And IoT is extremely complicated. There's lots of layers. And what I found myself repeating over and over again was the cloud middleware piece. So security, data protocols, connecting devices to the cloud to then another IT system. And so I set out to build a solution so I didn't have to build it again, really. But ultimately what Golioth is trying to solve for is helping every company building a product that has IoT as a part of it, not have to worry about the IoT infrastructure.
And this is complicated because you've got a fleet of devices, right? And so you need to roll out updates for them. Sometimes you may not want to do that to your entire fleet all at the same time because you could just ruin your own company. If you roll out a disastrous update, you also want to deal with product. There's all different types of problems related there. You got to get the data back up into the cloud. It's just so many different things and configuration issues you have to deal with.
Yeah, and actually it all comes down to data. There's parts of products that have around user experience, so convenience or extra functionality for an end user. But most of what we see and kind of the big problems we solve for is around data coming off IoT devices and getting it to somewhere. And there's a whole wide range of types of data. It could be accelerometer data, environmental data, but increasingly we're seeing folks building computer vision based devices that are actually IoT devices, and the camera is an important part of it. But getting a snapshot from a drone in the field over a cellular network into a system that can be tagged and sorted to then be used somewhere is a whole series of problems that again falls into that umbrella of how do we be that infrastructure layer for companies.
Gotcha. And I know I wanted to make this a fireside chat, but this fire is awfully hot.
It is.
We should turn it off.
Yeah, might as well.
All right.
The ambiance is set.
Yes, we did a fireside chat, but let's not die trying to do this.
But you do have a thermal camera. We can probably figure out exactly where it's going at right now.
Yeah, no, I wish, but fireplaces only have two options. They can be on or off. Maybe we'll turn it back on sometime in the middle of the interview when it gets cold again. Okay, yeah. No, but that's Golioth, and you guys offer a really interesting service here. So tell me, like, where are you guys deployed globally? Is everywhere?
Yeah, and middleware is this kind of bucket umbrella, but because we kind of sit in the path between devices and data, it's a very horizontal space we're in. We have drone customers, we have smart concrete customers, environmental monitoring, electric vehicles, and we are deployed everywhere. So we have customers all around the world as well, because the problems are so different. And even we have similar companies doing similar things, but targeting a completely different demographic. The nice part of being a software company, it truly is that we can support companies all around the world.
Yeah. No, I mean, that's awesome. That's awesome. That's what we want to hear. And tell me, so what are you excited about, like, coming into the future? Where's the growth going to come in the industry?
It's funny for those of us who've been in IoT for forever. We've all been looking at AI for the last 20 years. The hardware wasn't quite ready, the software wasn't quite ready, and the infrastructure, connectivity, et cetera. And I've been personally tracking the growth trend over the last 5 years, and it really feels like AI plus IoT is the killer app. And a lot of workloads, we were seeing people trying to do stuff that could really only be feasibly done with AI, but again, the hardware wasn't ready, the software stacks weren't ready, the open source libraries weren't there. And so we are seeing pretty much every conversation we have starts with, okay, we have this data problem, we have this computer vision problem, we have this audio problem, or this ability to solve this problem for a customer that can only be solved with audio or video or some other complex data source, which really gets unlocked with AI. So it's the sort of combination of edge AI and IoT is where we see most of IoT becoming. The two will be intertwined for the foreseeable future.
Okay, and that's where I want to pitch now the new OpenMV N6 powered by the STM32 N6 and the OpenMV AE3 powered by the Aleph Ensemble E3. And so both of these new OpenMV cams unlock that potential. The huge difference between these things, between what we previously were able to produce, is that these two systems have MPUs on board. And so just an example, on our H7 Plus, we can achieve about 0.3 frames a second running YOLO, V5 or such, a nano model, 224 pixels by 224, and that draws about 170 to 180 milliamperes. Depends on the H7 Plus or the RT1060, but you get about that performance. Okay, so not 1 frame a second, and you're drawing, it's 180 pi times 5, so pretty much almost a watt, really.
So it makes computer vision products possible,
but not quite there.
Yeah.
Now, the difference is when we launch on the AE3, for example, we've not just halved, we've reduced the power consumption to 60 milliamperes for the whole system when it's running at full power, down from 180, and then the frame rate is now 30 FPS versus 0.3. So that means an 100x performance increase and a 3x power drop in, a 3x less power. So 300x combined performance increase. And for the N6, you have similar numbers. We're seeing even faster frame rates, up to 60 FPS on that. So closer to 600x speedups on this system and 300x on the AE3. The benefit here now is all of a sudden AI goes from kind of working to, oh my God, it's here.
Yeah, and there's other side effects for the overall system. You're kind of thinking more about the IoT side. Mm-hmm. Besides unlocking use cases that just weren't feasible, you're now moving a lot more ability to process on the device. Mm-hmm. So you don't have to send so much to the cloud. So you're probably being more efficient with your bandwidth.
Yeah.
A lot of the applications we see have a cellular component, and the less you have to send to the cloud, the more you save on your SIM costs. Mm-hmm. And also, if you're doing that and maybe you're uploading data less frequently, your probably overall power consumption is going to be better because you're not sending and waking up the radio all that often. So it overall has just a humongous stepwise change in the kinds of IoT products you can build with these kind of hardware.
Oh no, absolutely. I mean, I think that's the missing piece. Folks aren't thinking about necessarily is they look at, okay, let's just the power draw of the system. But every time you turn on that Wi-Fi transmitter or a Bluetooth transmitter or a cellular transmitter, that's like 500 milliamperes to 300 milliamperes of power draw.
Yeah, totally.
And so that'll kill your battery life very, very quickly because that is more than the entire system. But it's necessary to make the thing do something useful.
Yeah, and there's all these other interesting things we talk a lot more about products than IoT as a feature. Mm-hmm. You start thinking about your overall product. I used to work at Nest, and mm-hmm. a lot of the embedded team was focused on thermals. Mm-hmm. And not because of overheating, but because it actually impacted other parts of the system. Mm-hmm. For example, thermostat has an onboard temperature sensor, right?
Yeah.
So they would time the radio and the other parts of the system such that the thermal it create wouldn't impact the overall measurements. Mm-hmm. So very complicated part. But now, as you go back to like these computer vision stuff or this edge AI applications, you have a symphony of components that all have to work together. It's your radio, it's your cameras, it's the MPUs and all the subsystems that have to effectively deliver the end product. And so the more budget you get back especially on something like the OpenMV, the more you have to play with for their overall product.
Yeah, let me tell you an anecdote about that. So we actually had the concept of building this tiny camera. So the OpenMV AE3 is 1 inch by 1 inch. Mm. We have a camera upstairs. Yeah, no, it's super tiny. And we could have pushed it a little bit smaller, but actually I chose 1 inch by 1 inch because it's a nice number.
Yeah, sure.
And I actually wanted to have screw holes on the sides so that you could mount it.
Screw holes are important.
Yes. We actually thought about mounting on some of this hardware too. It's not just a board that has no mountable features. We actually want to make it useful. But we built something called the OpenMV Micro, and we were excited about this concept of building a camera the size of a quarter. We wanted to do that for a long time. And so with OpenMV Micro, though, we powered the processor with 3.3 volts, and I think we used and then the processor needed to lower that voltage down to like 1.8 internally to run on its main core, and so it had a linear regulator that did that. And we're not thinking about, hey, it's not a lot of current, it's built into the processor, it's no big deal. Anyway, it turns out that little bit of heat injection from the CPU, generating its main voltage rail through a linear regulator, right? If you don't have a lot of PCB area, that heat has nowhere to go, and it can't escape because there's no heat sink of the PCB. You don't think about this often, but giant PCBs act as great thermal coolers for a lot of chips. And when you don't have a large PCB, these chips get hot. And so we actually achieved to the point where the OpenMV Cam Micro, when we first built it, it was burning your finger when you touched it. And we were just like, we can't ship this.
Yeah.
But then also the camera technology also was not in good shape. There weren't cameras small enough that we wanted to use that were cheap enough. And so one of the things that's enabled this new system is actually a partnership with PixArt Imaging, where they've given us access to a global shutter camera that's super low power, low cost, and we have the ability to integrate that right on the board to make the whole system very, very tiny.
And that's I think one of the there's obviously a lot of benefits to the OpenMV overall system and community, but I think the size of the solution is definitely a very big commercial benefit that we see. And there's lots of different ways you can build a computer vision system. Obviously, you can go all the way up to getting a Linux board and a big old camera on top of it. But going from being possible to create your ideas on the bench, but then actually taking that same solution and putting it in a product is, I think, a large part is just how impressive the size is, even with the previous generation.
Well, that's what we wanted to do with OpenMV. So, there's a few different core aspects of it. We aren't necessarily 100% open in our designs anymore, just because we do need to function as a company. And so we've had a few folks come up to us and be like, hey, we see your designs and let's just take it wholesale. And by the way, thanks for the code and the engineering work. Good luck on your own adventure. But we don't really want to allow that too much anymore. But we do want to be open in a way of supporting standardized processors and platforms. And so what I mean by this is we particularly support microcontrollers with public datasheet access. This is important for us, and we've been working to put our software on these devices. And the reason for that is we want it to be such that when you as an engineer want to go mess with the system or modify it, you're not stuck with, I need to email the sales guy at a company, and then they're going to ask you, how many units are you building? Oh, it's not 1 million? Okay, sorry. And that's the cold, hard reality, actually, if you haven't dealt in dealing with electronics, which is many companies are quite a lot.
What's your MOQ?
Yeah, pretty much. And for a lot of organizations, if it's not a huge number, they flat out will just not bother to interface with you at all. I'm not going to name the offenders of this, but there are actually many.
It's also, if you get into the supply chain, we deal a lot with the connectivity providers, whether they're the modules or the modems themselves. Their cell structure is actually not really well suited for, I'm a hobbyist or I'm a small volume. It's changing. We're seeing more, but we also invest a lot in open source. Even all of our device side code is open source because that same how do you enable the engineer using our product to get under the hood if they have to, fork if they have to, or in fact we've had people just rebuild some of our stuff.
I know. 100% of our firmware is available online, and so you can compile, edit, modify anything that you want. And then also for our hardware designs, we've actually integrated Altium 365 into every web page for a product. And so this means you can actually see the schematic link between the PCB, and you can also then do 3D views and such. And this comes along with CAD downloads, so 3D step files of all of our products. This way you can build cases and such.
And at the end of the day, there's an engineer at their desk. It's 2 a.m. They're trying to figure out why their code doesn't work. The open strategy allows them to go and figure out themselves, right?
Yes, that is the whole point. The whole point is I just want it to be, when an engineer is crying, why don't you work? I don't want it to be you have to email some other company and they drip out the information slowly. We want to enable folks, if you're a power user, we unblock you to do power user stuff.
Awesome.
And if you're not a power user, we try to make it easy for you to have a good experience.
That's awesome.
So the things are going to IoT, and AI and IoT combined are going to be the new frontier. What kind of applications do you see that can be unlocked by this?
Yeah, I'll probably focus on the ones that obviously are vision, because there's a whole bunch of other things.
Wait, stop for a sec. So the AE3 and the N6 both have microphones.
Nice.
And they both have accelerometers and gyroscopes that are perfectly co-located behind the camera center.
That's actually good for me to then also double click on, because One, we're seeing a trend towards multi-sensor applications where one sensor itself is not sufficient, whether it's fusing information or because it's complementary. So, you might be using sound and vision to detect an event, like for a security camera, right? If you want to know if the window's broken, you might have a computer vision to detect if there's an intruder, or the sound to break glass. More on just kind of like generally, computer vision allows for monitoring of physical assets. So that could be in agriculture. You could put a giant scale on the bottom of your grain, or you just put a camera at the top of the silo, and it becomes extremely simple to then monitor the usage, right? Or you're looking at things for wildlife or livestock, and like, did my animals graze enough? So we're seeing a lot of these kinds of products where just like monitoring assets or wildlife, etc. In the security domain, it's pretty popular. I think what's interesting, I spent some years working in physical security, so cameras and door locks, things like that. There's this very nuanced line of privacy that companies are trying to solve for. And actually, if you do more on the edge, then you have less data in your cloud to actually be.
And that's perfect here, because if you do have the MPU running on board, yes, you can take in a regular color image, and even though that would have privacy violations per se in there, if you saved it, if you process it locally and get rid of it, then you're never transmitting this information anywhere.
Yeah, and there's all these applications about where the company doesn't actually want the data. And so people counting for malls, state parks. For example, we see a lot of folks who want to know how many people are on a trail so that they can dispatch the rangers to go clean up trash cans and other things, right? So that's an effective way of managing it. But they don't care. They don't want to know who it is. They don't want to know anything about them.
And knowing that information actually opens them up to random liabilities, actually. So it's worse if you didn't have that information.
Totally. Now, there needs to be a cloud part, because they want to know, they want to count, right?
Yes,
so just count people, send the count to the cloud. That together, to do that yourself, let's say before Golioth and OpenMV existed, it's probably $1 million of engineering. I'm not understating that. But now it's grab a kit, sign up for an account, and you could do that in a week. So unlocking those kind of computer vision, doing processing on the device, and then sending some inference results to the cloud, there's just a ton of different ways to apply that.
Yeah, but it's also the battery life. I think the biggest power of these new microcontroller systems is that they have the ability to go into a deep sleep mode or standby mode. And so what is this? Standby mode is basically the processor turns off all of its voltage supplies. It is basically 100% off except for a real-time clock circuit and maybe some I/O pin interrupts. And these will then wake the CPU back up again. The benefit, though, is that when you go into these standby modes, your current draw is now in the microamp territory. And so if you're down to 50 microamps or so on a 100 milliamp hour battery, you're looking at a battery life of 20 years or so.
That's crazy.
So as long as you can stay in these once you're below 1 milliamp or so, we're talking battery life in the terms of years or months or years at minimum. And then if you can go below 0.1 microamp, if you can go below 100 microamps, then we're talking almost a decade of battery life.
Yeah, broadly speaking, most of the IoT applications we see, we do a lot of commercial, retail, smart city, smart building. Something's always asleep. There is very little reason to have something always on, and having a vibration sensor that gets wake on move that sends some information. That's very typical kind of application. It is very irregular to see a computer vision application because of the power, right? So you're going to sleep because you need to save on battery, or generally just your power budget. You need to save on data, or you don't want to send all of that data. And to me, it's almost like a stepwise change. I think I've said stepwise now twice. To think about computer vision and audio and accelerometer data in the same way we think of other simple sensors, because of the power and size profile with this new generation of hardware you have.
Yeah, no, but as you said, cameras unlock so many problems you can solve now, because with vision, you can suddenly have a sensor that does everything.
Yeah.
So this means, hey, you want to measure, count people. You want to measure the height of grain in a silo.
Yeah.
You want to measure your heart rate, which is I've heard possible by looking at if you have a high enough FPS, you can look at the color changing on someone's face, and using subtle color metrics of like 1 pixel differences, you can kind of guesstimate their heart rate, which is insane. I mean, it's these things work. I mean, there's so many different applications that you can deploy these systems for, and analytics, the counting is actually one of the biggest ones that I see. We've got customers who also mount cameras to do like physical device interface, where you have some previous older system that was not IoT connected. You can actually use a camera to turn that into an IoT connected device by literally staring at a problem, and now you have a sensor that can measure that.
The very first computer vision IoT application I saw when I was at Google was the solutions architect was building something very, very custom to take images, and I want to say like once a minute or slower, of a dial.
Yes, gauge reading.
Yeah, gauge reading. And it's like this custom bespoke thing, and you have to take all this, you have to build all your training data, and you then send it to cloud. We're talking about like minutes of latency when an operator could just go there, right? But gauge reading now is, excuse me. You can cut this part of my frog in my throat.
That's fine.
Now becomes a drop-in solution.
Yeah.
It actually is crazy 10 years later.
I see. Yeah, no, we have some customers doing that now, and it really is like the future. I think it's kind of amazing what they're doing with this technology. But I think it also stands to the deployment aspect of this, which is, I mean, think about it, like what's the difference in volume, you think, on what you can do with camera-connected devices compared to previous non-camera IoT systems?
What do you mean volume? Like,
just like, what do you expect to see in the industry? Like the kind of growth, is it going to be linear still, or are we going to see an exponential explosion of new systems?
That's probably a multi-million-dollar question if I could answer it. In general, we're just seeing layering on of more sensor capabilities. So where I think there's one trend line of projects that have a clear computer vision or a clear vision problem, and this technology unlocks that better. I mentioned drones. We have a customer doing drones with using computer vision and wildlife deterrence. So that's clear. But I think it's the unknown factor is when you start layering out other places where there wasn't a clear vision problem, but like you said, for aging in place and elderly, being able to monitor their health. There's a lot of these 60 gigahertz sensors that are deploying in aging facilities, detect breathing and fall. Yeah.
With radar.
With radar, right? So now what if you combine that also with a camera? So now the system is both radar and camera. I think it's going to make the applicability of that product, or for the companies who are building those, maybe that one extra use case that prevented someone from buying it now unlocks it because of these two. And given the price point and again the kind of robustness of the solution, it means more and more of these companies can now add vision to expand what they could do for their existing products. So I think there's just like clear use cases that are being unlocked, and sort of the 1 + 1 = 3 kind of thing. Now that vision is so easy to reach for all these IoT products.
Yeah, no, it's going to be an amazing future. I think, and to wrap up this conversation, Jonathan, and thank you for having it.
Oh yeah,
I just want to ask, what's Golioth preparing for in the future? What are you going to be building?
Yeah, so last year we really started getting involved in the AI part of customers' middleware, and so we had a bunch of announcements. We did some demos with you as well, showing and trying to solve for the problems that data plus AI needs with IoT. We're definitely doing a lot more with AI enablement, things around managing AI workloads, being able to deploy AI models to a device. We're hearing a lot of customers deal with, different AI models per device because of unique parameters. So they train it at the device level.
That's quite interesting. Yeah. That means a huge need for an orchestration platform.
Yeah, and the orchestration of the AI models is different than the orchestration of the firmware on the devices. So you might have a golden firmware image for all of your sensors in the field for the battery management, the IoT connectivity, but then you need to update the models independently. And so if you have unique models per device, then you have a whole new series of problems.
Yeah.
And then you have drift associated with it too. So now you have this heterogeneous mix of models that are updated independently, that are drifting over time. And so, in that space, and we already announced a bunch of stuff, but that's where we're going to continue to invest. And the more we can do with getting data from devices, not just computer vision, but other types of payloads, we continue to invest more and more in that.
You'll like to hear this then. So for both the OpenMV N6 and the OpenMV AE3, we actually have a few technical innovations we've done to make this easier.
Cool.
So on the AE3, for example, it's a really rich SoC system. The main processor actually has about 13.5 megabytes of RAM on chip. Yeah, a 6 millimeter by 7 millimeter package, by the way. It's a 400 gigaopt neural network computer, 2 processors, another 40 gigaopt NPU, because it's actually dual core, which I should mention before we go. I want to plug on that.
Cool.
And it also has a GPU on board for image scaling. Yeah. It's like a superpower in chip, But one of the things on board is that the different memory regions allow for, there's something called MRAM, which is like a new version of Flash. It's not Flash, but you pretty much acts as Flash, but faster writes and reads. And so that MRAM is where you store your main application images for all the cores. Then externally, though, we have an OctoSPI flash, which is a new standard. I don't think many people have seen it, but folks know what QuadSPI flash is right now. So OctoSPI is 8-bit DDR at 200 megahertz performance.
Nice.
And so it's actually 400 megabytes a second on the OpenMV N6 and 200 megabytes a second on the AE3. The benefit is you can execute in place off of it, right? So what we do is we partition that OctoSPI into 2 segments. One is our FAT file system for MicroPython, and that is mounted to the PC. When you connect it to the computer, that appears as a USB flash drive. You can drag and drop files in there. You can put assets. But then we have a new file system called ROMFS that we're pushing out. And so ROMFS is a linear file system.
Makes sense.
So FAT is, FAT has something called a file allocation table. And what happens is after you write to it, files actually get scrambled and, what parts of them are where.
Good old Windows 11.
Yep. It keeps going.
Yeah.
But with ROMFS now, this is basically computed on the computer, so you concatenate all the files together. It creates a record, and then it also does memory alignment, which is very important for all these hardware accelerators because they totally break them instantly the second you're off by 1 byte or something.
Yep, that's why Delta updates are hard.
Yes, absolutely. So the ROMFS linear file system, every single file is aligned to the right memory regions, and then boom, MicroPython, which you run on board, actually allows you to get you basically give it a file path. Here's the string of the folder, because we support folders too, so folder and file path. And then that returns internally the address of the file. And so then the MPU can execute that model in place off of the OSPI flash.
That's super cool.
And it's huge because now you can just update those models willy-nilly and you never have to touch the firmware. And then for post-processing the models, we actually have that implemented in something called NumPy. So we can run the NumPy library on board these systems. And this allows you to handle all of the massive vector operations you need to basically handle the post-processing of a YOLO model and do non-max suppression on the output to find the bounding boxes and so on and so forth.
Nice. I know what all those words mean.
Yes.
Our customers know all those words mean, but I'm glad that you're solving it for them.
Thank you. No, well, the reason I mentioned this is just to say that when he said you need to be able to ship new models separated from the firmware, we have that support built in because you can ship a new ROMFS, right? And you can ship a new MicroPython script, for example, to our camera. And the firmware doesn't actually need to be updated, but you can keep continuously deploying a model.
Yeah, and I was a little bit tongue-in-cheek. It's like, that is actually the hard problems that customers have to solve for. We're in the business of getting bytes over the internet onto the device, and we've done tighter integrations, and we've seen how hard it is to build out their file data payload management system. So that's super cool, and I definitely expect people to use that.
Yeah, no, it's what was important for us because it's just one of the tricks with these microcontrollers is that you have to actually reuse your resources, pretty carefully. Loading a model into RAM takes space, and you want to use that space for your tensor arena where you actually compute the model outputs and such. And so having the model itself wasting half your memory when it's floating around when it could just be on disk really helps change the game for us.
Awesome.
Okay, but I cut you off in the middle of it. You were still talking about the IoT pipeline orchestration and.
So just in general, enabling, we call it AI enablement from the MLOps, the model management for large fleets, complicated fleets, heterogeneous, and then also on the data collection side.
Yeah.
Right. We've seen early use cases where you send, accounts, but what if you need to have the frame? What if you need to have distilled information? What if you need raw binary data? And how do you manage binary streams? So we continue to invest on the what we call pipelines. And make that unlock new use cases.
Can you tell me a little bit more about pipelines?
Yeah. So pipelines is probably several iterations for Golioth on how we help customers deal with the problem of data. Because when we first started, we just focused on sensor readings, so like strings, whether it's raw strings coming off of basic sensors. But a few years ago, we started to see people running into issues where they want to send binary data. So we went from strings to binary data, and that was fine. You can shove some frame into a packet, and then we can chunk it up for them and send it over the internet, and then decode it. But that still left a lot to do in the cloud. Like, let's say you had an image, you had uploaded it to the cloud. Well, if you chunk it up, we chunk it up, and then you get it on the other side. Well, now you have parts of an image that you have to then unchunk and put together, and then store it into like a cloud storage. And so we saw a lot of these processing challenges, even irrespective of the end product, like pre-processing, taking data in one format and the other. And so pipelines is our data services. It's under one bucket, where we make it easy to ingest, transform, enrich, and ultimately send data to a huge array of destinations. So to give an example, maybe you're going to be sending image in one format over the internet. Maybe it's a raw format. You can call out to a third party that might re-encode that image. So it's an easier format to work with, and then we can stream that to an AWS backend. That whole configuration is probably 4 lines of YAML code. So you have a low-code implementation on it, and you can do a whole bunch of other stuff like taking highly compressed data and in binary format, convert it to standard JSON format, and then convert it again, and then call it to an API to enrich the data to then send it to Google. And so all these things is ingestion, transformation, destination is all part of our platform, wrapped up in a nice low-code format.
And so this could be, for example, I could have a fleet of devices, and they could be connecting to the internet, and then they just stream all their data back to Golioth. And then Golioth could actually be doing API calls to all different types of services to do all kinds of fun stuff with that data. Like taking the images, training with them, getting new models, and sending the models back. But this saves the user having to put all of that intelligence on the end device and have a crazy, massive application that's calling tons of services.
Yeah, in fact, like most of the time, it's not even feasible upon the device. It ends up being, you're going to have to build all these cloud services to glue code together before we even build our product. And so we're very much focused on sort of in the path of the device data. And then once it gets into the we call it the big cloud, then web developers and backend engineers can solve for it. So maybe I'll use a concrete use case. We have a case study on this. There's a company called Phlox. Drone, they do real-time on-device wildlife detection. And they don't send all the data to the cloud. So first, they have some training data. So they send, when they're doing training, they take those images, send it over to cellular network, and put it into their AI infrastructure. That is one pipeline. But then they have AI models that they generate from their custom AI infrastructure. Well, then they push through Golioth, so that's that MLOps. But they have the ability to send images also in real time. So if there's a detection event, they might send that through a different pipeline. So you can actually slice and dice how the data is routed. So when they enable through a configuration to go into training mode, they'll send more photos through to S3 on AWS. And then when it's not, they'll only send a deterrence event through another pipeline. And so all that glue code of taking images, transcoding it, tagging it, then routing it to where it needs to go is all part of the pipeline. It's pretty standard use of pipelines for image stuff. And there's a ton of other use cases.
No, but I'm so excited by this. And so in order to enable Golioth, what we're going to be doing with OpenMV, we're still working on these products, so we don't have them physically here, but we're going to be offering a cellular shield for both the N6 and the OpenMV AE3, just to talk about connectivity. The OpenMV AE3 supports Wi-Fi and Bluetooth standard built in. It's by default, both of these things ship with chip antennas, but they have an option for a UFL antenna to be added, so you can do a little stick off and have fun that way. We just didn't want to do that because it looks ugly by default.
Yeah.
But that's the default antenna. So Wi-Fi and Bluetooth are on board, but then we're also going to be supporting cellular shields. So for the AE3, you'll be able to mount a little shield in the back, and that'll give you LTE Cat M1 and MBIoT along with GPS support. And we're looking at the NRF 9151 to power these systems.
From Nordic Semiconductor.
From Nordic Semiconductor, and this works with Zephyr OS. And that allows the NRF 9151 to act as a controller system that can reboot the OpenMV Cam, load firmware, and do anything necessary to provision the system and repair it. And then we'll have the same thing for the OpenMV Cam N6, but in a different form factor that mounts onto it like a shield.
Awesome. Yeah, and we've seen a lot of configurations. Some people call it a network co-processor, some people call it a comms module, but combining the two actually, one, it obviously makes it very easy to develop cellular-based computer vision applications, going to be in that backpack. But it separates the concerns, right? Because IoT is one stack of concerns, and computer vision is another stack of concerns. So we've actually seen customers build, bespoke kinds of architectures, and allows them to, once they get their bearings around their IoT parts and integrate Golioth, then just focus on the application, which is computer vision, and putting that into a backpack and sort of integrating into the OpenMV ecosystem just makes it that much faster to get started. And we're obviously very excited about what you're doing. So
and the benefit of this is it actually helps you, honestly paper over any problems per se. Versus if you're concerned about security, authentication, all these other various things, you can put that all into the Nordic system, which is built for this. And that gets you Zephyr OS, which is a widely supported operating system. And so you can focus on a lot of those problems on that. And then you can have a lighter system running. Well, you can fully focus on having the OpenMV Cam be the metal there that is running the models, but you don't have to put all of your certs and everything else on that. We want to make this available for people if they're not comfortable with MicroPython just yet. We hope they will be in the future, but we wanted to make it so that you can get the best of both worlds. You can get the ease of use of running AI, ML models and have a system that does that, but then also have the certainty, the security, and the guarantees you have with a more standard type of system.
Yeah, and we have customers from all levels of experience, but also focus area. Zephyr is a great open source operating system. We're contributors, and we have native support and very well support for both the Nordic platform and Zephyr. But a lot of companies don't have the resources to focus on IoT, and so by combining our platform and the hardware, will make it just, I think, a lot easier for these connected products to get to market.
And just a question: can we run your firmware on the Nordic NRF 9151? Could there be like a Golioth module? Is that something we can do?
Oh yeah. So we provide an open source SDK called Golioth Firmware SDK. It has native support for every Nordic cellular part that has ever existed. We're actually the first ones to connect to the 9150 one. We have a blog post about that. And so not only is it supportable, we have extensive testing that we do with our hardware in the loop testing. So we literally have 9160s, but they're very similar. That every commit, every time we do a release, it goes through a batteries of physical tests on a 91 series hardware with cellular connectivity. So it's really robust testing that goes into it, and we have customers who've deployed it in the field. So we can package that up and make that a really nice experience for the backpacks.
No, that's awesome. So we're going to have the date to be decided.
Yeah, sure.
A lot of engineering work to do, but the hope is, and the dream is that we will have an easy to use way for low power microcontroller-based computer vision that has high performance. And we're going to allow that and give that feature to everybody.
That's amazing.
Make that possible and make it ubiquitous. Thank you.
Thank you so much, Bhavana. Always great to see you.
Yeah, appreciate you coming out. All right, we should turn the fireplace back on and burn ourselves alive.
All right, that was fun.